Okay, good morning. Listen. Okay, today's portion. Uh, Today that I had to discuss about the forward bias and reverse bias. What is forward bias? Characteristics of forward bias. What is reverse bias? Characteristics of reverse bias. All these concepts that we are supposed to learn. But before learning all this concept, you must be aware of PN junction. If you don't know the PN junction, that we cannot understand. Okay. So I told you last class about the PN junction. This is a PN junction. Already we have come across about this PN junction. Semiconductor diode. Okay. So in the case of PN junction, here, there is in the border P and N, there is a border here. In this border, there is a region which is not containing the mobile charges. It is containing only the immobile ions. That immobile ions region, whatever it is present here, that region is called by the name charge depletion region. The thickness of charge depletion region is equal to 10 to the power minus 6 meter. If it is made up of germanium, then this potential, whatever it is occurred at the junction here, P and N junction, P and N junction, whichever the potential is existing here, that potential is 0.3 volts for germanium. The junction potential 0.7 volts for silicon. This much already you have understood. All this concept already we have understood. Now further, so here there is a charge depletion region whose thickness is 10 to the power minus 6 meter. And here there are majority charge carriers, electrons, minority charge carriers, holes. If I am applying an electricity here, these electrons, if they are moving from here to here, then that current is called by the name diffusion current. But due to the thermal energy, if the covalent bonds are breaking up here inside the germanium, and the holes and electrons are recombining here, that current setup is called by the name drift current. I think I told you yesterday about that. Okay, there are two types of current here. Charge depletion region do not containing any mobile charges, contains only the immobile ions. The thickness is 10 to the power minus 6 meter. There are two types of currents are existing. One is the diffusion current due to the majority charge carriers passing from N variety to P variety here. Drift current within N variety or within P variety, the minority charge carriers, they are combining here, and hence it is producing another small current here. Now this current is larger, this current is smaller. That current is called by the name the drift current. So diffusion current, drift current, two types of currents is said to be existing in the case of diodes. Okay, now, yes, you are already aware of the diode means what? Semiconductor diode. Now let us go for, I told you already, the semiconductor diode. Semiconductor diode. This is like this. Either it is germanium or silicon. Here there is a junction potential. Here there is a junction potential. I told you already about this. P variety, that says that is that side which is containing the negative. This is P. This is N. This side is having negative. This side is having positive here. And here majority charge carriers are electrons. Minority charge carriers are holes. Here majority charge carriers are holes. Minority charge carriers are electrons. Here only the positive and negative charges are present here. These are the negative ions. Negative ions are present here. Here positive ions are present here. These ideas already we have come across, and this thickness is equal to here 10 to the power. This thickness is equal to 10 to the power minus 6 meter. This is the thickness of the charge depletion region. This voltage is equal to 0.3 volts for germanium or 0.7 volts for silicon. So we have studied all these ideas already. I have shown it also again. Okay, any doubt if you are having, okay, you can inform me. I can show that particular aspects in the evening classes. Okay, or any other timing also I can put it. The recorded one I can put it. Okay, just you see here now. Further, the symbol for this semiconductor diode symbol. Of course, here we are going to insert, or maybe we are putting here, there is an aluminum wire. Here also we are putting an aluminum wire for the electrical connection. Okay, this is a diode. This is diode. Symbol, we are writing a diode symbol like this. This is diode symbol. Okay, this is a diode. This is P, this is N. If possible, I will show the diodes also. I will see the circuits. If any broken circuit is there, I will open it and I will show it. Okay, capacitor, resistor, diodes, transistors, everything I will show it. Just to see that. Okay, this is a diode. This is a circuit symbol for diode. This is P and this is N. This is the junction. This is aluminum wire. This is aluminum wire. This is another aluminum wire for the electrical connection. Now we have to start today's concept. Up to here, I have summarized the yesterday's portion or whatever we have already learned. So the first concept, what do you mean by forward bias? First of all, biasing means what? Biasing, biased, biasing. What is the meaning of biasing? Okay, you know about the personal biasing, about the commonly what we are going to ask as biasing. The teacher is biased. Let us consider two students are there. Two students, they have written the same answer. Same answer they have written. But a teacher is giving full marks for the one answer and nothing marks is given for the second one here. I can say the teacher is biased. Teacher is unbiased for both the persons putting 0. Teacher is unbiased for both the students if you are putting full marks. It is unbiased. Biasing for one student treating one way, for another student treating in the other way. That is biasing. Parents biasing. Parents biasing. If two children are there, if one child is working or maybe studying very nicely, good way, then giving all the facility, okay, new dress, everything, then biasing. For the other one is not studying, not giving anything, it is biasing. That is the meaning of biasing. Meaning only, to take it for the meaning purpose. It is meaning of biasing, that is. Electronics also we are putting biasing. Either forward biasing or reverse biasing. First, what do you mean by biasing here? We are having the two terminals here. We are having two terminals. Here also we are having two terminals. Out of the two terminals here, for one terminal, we are connecting a positive polarity of a battery. For the second terminal, if we are connecting a negative terminal of a battery, for one terminal negative, the other terminal positive, I can call it by the name biasing. Either this is positive, this is negative, or this is negative, or this is positive. For example, if this is positive, this is also positive, sir, it is unbiased. This is negative and this is also connected to negative, it is unbiased. But this terminal connected to positive terminal of a cell, this is connected to negative terminal of a cell, called by the name the biasing. So therefore, biasing, there are two types of biasing, forward bias, reverse bias. First, let us learn about forward bias means what. In the case of forward bias here, I will write it here just to see that what is happening here. This is what is happening in the case of forward bias. This is your PN junction. This is a PN junction. This PN junction, P variety is present here, N variety is present here, holes are present here, more number of holes, more number of electrons, majority charge carriers that I supposed to write. This is aluminum wire, this is aluminum wire. Here there is charge depletion region, this thickness, charge depletion region. Here holes are present. If you want, I will show it that also. Holes are present. Here, electrons are present more in number. Majority charge carriers are electrons, minority charge carriers are holes, majority charge carriers are holes, minority charge carriers are electrons. Now, what do you mean by forward bias? Forward bias means P variety, we have to connect it to a battery. We are supposed to select a battery. You know about how to write a battery, even from the maybe high school level also you have studied. We had to connect like this. This is positive end of a battery or a cell. Negative end must be connected to here like this. This is a copper wire. Using a copper wire, this is a cell or it is a battery. Cell or a battery. You know about the cell or a battery. The battery or a cell is present like this now. Market. In the case of market, whatever the battery is present, okay, it is present like this. This is a battery or a cell. This one is acting as positive, this side is acting as negative. Take a wire, connect here and connect here. That's all. This is positive and this is negative. Okay. Here it is written as 1.5 volts is written. 3 volts is available, 20 volts is available, all these things in the market. Okay, yes, right. Coming to the concept. So here I will consider P and N. P variety connected to positive, N variety connected to negative. Then what will happen here? These are all holes. Holes are having a huge amount of the number here. Electrons number is also more here. But this side is connected to positive. Holes are having the positive charge. Holes are having the positive charge. Here also positive. Positive, positive, there is a force of repulsion. These are electrons, negatively charged one. These are all negatively charged one connected to negative charge of a cell or a battery. This negative potential repelling these negative charges, positive potential repelling these positive charges, means holes. Means I can say holes are repelled here by the positive potential. Here, electrons are repelled by the negative potential. N is connected to negative, P is connected to positive, is called by the name the forward bias. So what is that? I can show it like this circuit wise. This is diode, this is diode, this is P and this is N. We are having a battery here. This is a battery. This is a battery. The battery is possessing positive and the negative. For this battery, I will going to connect from P variety. I will connect a copper wire and I will connect like this. From N variety, I will take a copper wire and I will connect like this. This is called by the name forward biasing. This idea is called by the name the forward bias or forward biasing. Now, what is happening here in this case? P, which is said to be having a huge number of holes, majority charge carriers are holes. N variety, majority charge carriers are electrons. Holes are repelled by the positive potential. Electrons are repelled by the negative potential. Holes are repelled by the positive potential. Positive, positive, there is a force of repulsion. Negative, negative, there is a force of repulsion. Positively charged holes are repelled by the positive potential. Negatively charged electrons are repelled by the negative potential. Once it is repelled here, these holes are drifting like this. Drifting, pushing. The holes are pushing like this. Electrons are pushing like this. Holes are pushing like this. Electrons are pushing like this. As the holes are pushing like this and electrons are pushing like this, here the charge depletion region thickness is going to get decreased. Here it was 10 to the power minus 6 meter. Electrons are pushing like this, holes are pushing like this. Therefore, you will be having the charge depletion region here. Now, the charge depletion region thickness is going to get decreased. Point number 1. So, what is that point number 1? Okay. P is connected to positive end of a cell. N is connected to negative end of the same cell. Point number one. Point number two. Holes are repelled by the positive potential. Holes. This is in P side. They are repelled. Okay. Electrons in N side, they are also repelled. These electrons are repelled by the negative potential. Holes are repelled by the positive potential. Due to that one, what will happen? The holes are little bit moving here. Electrons are moving here. Now the charge depletion region thickness, it was 10 to the power minus 6 meter here. It was 10 to the power minus 6. Now it is not equal to 10 to the power minus 6. Here, the charge depletion region thickness is going to get decreased. Monisha is asking a question. What is that? P region consists of indium and it is, I'm not saying. Of course, here it is ions are there. Ions are there. Here ions are there. Charge depletion region, ions are there. Here ions are present. Charge depletion region. Here there are no ions. Here there are no ions. Charge depletion region, only ions are there. But the ions, they are going to get contracting like this because they are all pushing like this. Electrons are pushing like this. Holes are pushing like this. I hope you understood. Due to that one here, number 3. Okay. Charge depletion region thickness. The thickness of the charge depletion region thickness decreases. It has been decreases. This is most important concept. So here P variety connected to positive, N variety is connected to negative. Holes are drifting here, electrons are drifting here because electrons are repelled by the negative potential, holes are repelled by the positive potential. In this charge depletion region, we are having only the arsenic ions and indium ions are present here now. These are all moving like this, Just like last 1 or 2 days, what is happening between India and China border? Okay, Chinese are coming like this. Because of that one, Indians are also moving like this. Nothing else. There is a clash, of course. The line of control is present here. There is a clash. If they do not move here now, Indian soldiers could not be able to move. Why they had to move? Okay, line of control is there. They are present here only. They are also present here only in their inside the border. But because of this influence here now, because of this influence, okay, Chinese president influence, Chinese soldiers, they are crossing the border. Okay, because they are crossing the border, then Indian soldiers, they have taken the permission and they are also moving here, certainly. Then there was a clash. Sir, there is a line of control. Why they are forcibly they are moving. Okay. So coming to the concept here, electrons are moving here, holes are moving here. Therefore, the charge depletion region thickness is going to get compressed. Therefore, thickness is going to get decreased. This is what is happening. Charge depletion region thickness decreases. I hope you understood. Now, going back to the junction potential here, 0.3 volts for germanium, 0.7 volts for silicon, 0.3 volts for germanium, 0.7 volts for silicon. Here, if we are giving here 0.1 volt compressed, 0.2 volts compressed, 0.3 volts it is compressed if it is germanium. If you are giving 0.3 volts, then electrons, they are jumping over and they are moving here. They jump over here and they are moving. They cross the border. They are crossing the junction here because here the junction potential is present. The junction potential, I have shown it already. The junction potential is 0.3 volts for germanium and 0.7 volts for silicon. If this material is made up of germanium, PN junction is made up of germanium. If we are giving 0.3 volts here, now the electrons here, they are crossing the border and moving here. Then current is passing. That current is called by the name What is that? Diffusion current. As you are applying 0.4 volts here, more electrons are moving here. 0.5 volts, more electrons are moving. That current, whatever the current is set up here now, that current is called by the name diffusion current. Going back here, if this is made up of silicon material, in your practicals you are having forward bias. It is there in your practicals also you are having. Forward bias, silicon we are using. In your practicals we are giving the silicon diode. Silicon diode if we are using, the junction potential is 0.7 volts, 0.7 volts. If you are applying here 0.1 volt, no current. But junction potential, I mean junction, it is going to get decreasing its thickness. Charge depletion region thickness decreases. But electrons are not passing here. 0.2 volts, 0.3 volts, 0.4 volts, 0.5 volts, 0.6 volts. No electrons are crossing here. You are going to get the current is equal to 0. 0.7 volts if you are putting here, more electrons are moving from here to here. Current is set up. If it is made up of germanium, up to 0.3 volts, no electrons are jumping. If it is made up of silicon, up to 0.7 volts, electrons are not moving. If you are applying the 0.6, 0.7 volts here now the electron starts to move from here to here, jumping over this potential, junction potential, whatever it is there, it is jumping over that and it is crossing the border and it is moving. This current is called by the name diffusion current. So again, I can repeat, if it is made up of germanium, if you are putting 0.3 and above volts here, electrons are moving like this. Sir, less than 0.3 volts, electrons are moving like this, but could not be able to cross the border. If it is made up of silicon, up to 0.6 volts, if you are giving here now, electrons are moving here and stop. 0.65, 0.7 volts, if you are giving, electrons starts to move like this. 0.8 volts, more electrons are moving. 0.9 volts, still more electrons are moving. Okay, like that, current is set up here. And hence here, charge depletion region thickness decreases. Point number 4. As the charge depletion region thickness decreases here, now I can say resistance. Opposition for the movement of electron is called by the name the resistance. 10 standard concept. 10 standard, you are having the electricity, electric current. According to that, I can say resistance means what? The movement of electron, the movement of electron having an opposition, having a kind of stopping effect is called by the name the resistance. Here, the electrons easily it is moving here. Hence, I can say resistance is low. Resistance is low here because the electrons can easily moving. So how much is the resistance here? Approximately around about 2 ohms you may get. Okay, approximately I said. Not necessarily exactly the 2 ohms here now. Approximately maybe 1 ohm, 2 ohm, like that you are going to get. That is a resistance. Okay, anyhow, resistance is lower here because of that one. Electrons are moving from N variety to P variety. Hence, there is a flow of current. Current, it starts to flow. Of course, it is said to be the majority charge carriers current called by the name drift current. So, drift current is going to be passing here. Due to the drift current here, electrons are moving from here to here. Is it clear? This is about the forward bias idea, still is not yet over. So, P variety connected to the positive, N variety connected to the negative here. Then here electrons are passing and hence there is a current that is flowing provided this potential is more than the junction potential. Junction potential is there for the germanium 0.3 volts. If it is more than that, current it is passing if it is made up of germanium. Silicon junction potential is 0.7 volts. If it is more than 0.7 volts, if it is made up of germanium, then only electrons are moving here, then only the current is set up. So in the case of forward bias here, P variety connected to the positive, N variety connected to the negative. See that condition, P connected to the positive, N connected to the negative is called by the name the forward bias. Holes, they are repelled here and hence they are moving away from this position. Electrons are repelled by this negative potential, moving away from this one. Hence, charge depletion region thickness is going to be get shortened, or I can say thickness is going to be get decreased. As the thickness decreased here, now I can say resistance is lower. The resistance is lower means electrons easily it is moving. Easily it will pass the border and it will be moving. Resistance, no resistance is present. Okay, therefore, if the resistance is lower or very low resistance is present, electrons easily it will pass into the p variety and they are going to get conducting. Now, next concept under forward bias. Forward bias characteristics. I will finish up this. Forward bias characteristics. Tomorrow I can take up reverse bias. I will finish up this characteristics also. Practicals. It is there in our practicals also. Practicals containing the forward bias, of course. So what is that forward bias characteristics? So this is a diode. Circuit wise, this is P and this is N. We are supposed to connect this one to a positive end of a cell, and N variety must be connected to the negative end of a cell or a battery. This is called by the name forward bias. This is forward bias. So P is one more question. What do you mean by forward bias? The diode P variety connected to the positive end here. The diode N variety connected to the negative end of a cell. Then that connection is called by the name the forward biasing. So in this case here, charge depletion region thickness decreases, resistance is going to get decreased, current flow is going to get increased. There is a current flow, of course. There is a current flow. Resistance is low, therefore the current is said to be existing here. I will write it here. Due to this, point number 5, there is a current flow. There is the current flow. Flow of current is present. This current flow is larger. There is a larger current flow. If it is a larger current flow here, point number 6, I can say diode is conducting. We are going to say diode is, for all practical purpose, we are going to say it is conducting. We are going to say there is a current flow. The current flow is larger. Hence, we are going to say diode is conducting. Coming back here now, as soon as if it is present here now, current is said to be a larger current is flowing. Resistance is said to be a lesser resistance, and hence diode is conducting. Diode is conducting, we are going to say. It is conducting, it conducts. Current is flowing. Current flow is larger. Current flow is larger or maximum. There is a maximum current flow that takes place here. Therefore, diode, for all practical purpose, we are going to say it is conducting. When it is conducting, when it is said to be under forward bias. If it is under forward bias, then the diode is conducting, current flow is maximum. Then what we are going to do? Here we are connecting like this. Just you see here, this is a diode. This is a diode. This is P and this is N. Next, we are connecting here one current meter. We are connecting here. That is milliammeter. Milliammeter we are connecting. Current measuring device. We are going to measure the current, how much it is flowing here. That one we are connecting, and we are connecting a battery, positive end, negative end. We are connecting. That's all. That's all what we are doing. Here we can increase the voltage. Okay, if I'm writing like this, it is not striked off. The meaning is said to be, there is a, just like your fan, there will be a knob here. That knob we can increase the voltage or we can decrease the voltage. Just like the fan regulator, electronic fan regulator. If you are rotating like this, fan speed is go on increasing. If you are rotating like this, fan speed is go on decreasing like this. Here also, this is the meaning, variable voltage. If I'm writing like this, variable voltage, meaning we can increase the voltage or we can decrease the voltage. That is the meaning. Okay, so here we can increase the voltage or we can decrease the voltage. So milliammeter we are connecting like this to measure the current. This is to measure the current. This is we are applying the voltage. Okay, yes, you are applying the voltage here 0.1, 0.2. Let us consider this is made up of silicon. This is silicon diode. Let us consider this is made up of silicon diode. Now we are asking you to make a tabular column like this. A tabular column we are supposed to write it, and here you are supposed to plot it. This is voltage V in volts we have to plot. This is current I in milliamps. I representing for current, V for voltage. We have to start here 0.1 volt, 0.2 volt, 0.3 volt, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, enough. Okay, for all these things we are supposed to measure the current and we have to write it here. For example, you increase the voltage to 0.1 volts. Of course, 0 volts. 0, current is 0. Increase the voltage to 0.1. It will show here 0.1. Of course, if you want to have a voltmeter, you can connect here. A voltmeter also you can connect if you want. Otherwise, here only it will show. If it is a power supply, it is going to show the voltage also here. Digitally, it is going to show. Digital one. Digital meters are available. Digital meter, it will show 0.1. Note down the current here. It will show 0. Why it is showing 0? Already I explained. Again, increase this one to 0.2 volts. 0.2 volts you increase here. See the current. 0. No current because electrons are not moving. Here, put it in as 0.3 volts. Current is 0. 0.4 volts. Current is 0 because it is made up of silicon. Junction potential is 0.6, 0.7 volts. 0.5 volts. 0. 0.6 volts you will get. Some amount you will going to get. Maybe it is said to be 2 milliamps you will get. 0.7 volts if you are putting, you are going to get around about 28, 30 like that. 30 milliamps. 0.8 volts if you are putting, you are going to have around about 100 milliamps. 0.9 volts, you will be having around about maybe 150, 200 like that. Like that you are go on increase. It is go on increasing here. As a voltage up to here, you are not going to get any voltage. Just to see that. This is junction potential. Don't forget. Now we are asking you to plot a graph here. You are supposed to plot a graph. Okay, this is a graph sheet. Here you are supposed to plot the voltage V in volts. You have to plot. This is current I in terms of milliamps. You have to plot. Here 0 volts, 0 current. 0.1 volt, 0 current. This is 0. This is 0.1. This is 0.2. This is 0.3, 0.4, 0.5. This is 0.6, 0.7, 0.8. Like this is present. Here, you are supposed to plot it here. 1 centimeter. How much? You have to take the units, scale properly. You have to choose it and you have to plot it. Okay, up to here, you are going to get 0, 0 only. This is 0, this is 0, this is 0, this is 0. No current. This is 0 here. This is also 0. 0.6 you are getting 2. 0.6. 0.7 you are getting 30. Maybe somewhere else here. This is around about 100 you are going to get. Like this. This one you are going to get 200 somewhere else here. Plot all these things. Once it is plotted here, you are supposed to draw a curve. You are supposed to draw a curve. I am drawing a curve like this. Up to here it is 0. Like this we have to draw. This curve is called by the name forward bias characteristics curve. Voltage versus current we have to plot. The curve is, this is the practicals. Whatever I taught is said to be the practicals concept only. You are supposed to do all these things in your practicals. Voltage versus current, we have to plot. Whatever the graph we are getting, you connect all these points using a smooth curve. Smooth curve, you should not draw like this. No. So smooth curve we are supposed to draw. Okay. This curve is called by the name. What is that? Forward bias characteristics curve. Now we are supposed to put a scale. We are supposed to put a scale here like this. And we have to draw a straight line. We are supposed to put a straight line like this now, scale, and draw with a scale. Draw with a scale like this. Where it is meeting here now, where it is meeting here, this is called by the name knee voltage. This is called by the name the knee voltage. Meaning at that voltage, current is said to be shooting up. At this voltage here, current is going to be shooting up. That is said to be your junction potential. That is your junction potential. That is a knee voltage. I can write that one as V suffix K. V suffix K. This is knee voltage. Here, wherever the straight line graph is present, in the straight line graph, we are supposed to draw a small triangle here. Okay. Graph sheet is having the lines now. We had to coincide with the lines only. We had to draw the one small triangle here. This is the voltage. This side is said to be the delta V. This is current here like this. This side is said to be the delta I. Now, resistance is equal to this voltage delta V divided by this current delta I. This value approximately equal to around about 1 volt, 1.5 volts, 2 volts like that. 2 ohms like that you are going to get. This is said to be a lower value. This is lower because it is a forward bias.